This video will help you identify a function. So first, let's make sure we define what a function is. So to be a function, the relation has to be such that every input has exactly one output. So the input is typically x and the output's typically y. Of course, we can use different variables from x and y. So if we are sticking with the or x and y, we could say for every x there is only one y. So let's start with an example. Let's say a teacher surveys her class. She asks how long in hours each student spent studying for an exam. She compares time spent with the grades. So we need to identify the independent and dependent variable. We discussed this in a prior lesson, so I would pause the video and see if you can identify whether the time spent studying or the grade is the independent and which is the dependent variable. So hopefully you're thinking the grade on the exam is dependent on the time spent studying. So since the grade on the exam depends, it's the dependent variable. We also call that the output variable. So that would leave us with the time spent studying as the independent variable, which also is called the input variable. So the independent variable is the time. It's measured in hours that the students spent studying, and the output or the dependent variable is the grade on the exam, and it's measured in percents. So we are asked if this is a function. So again, to be a function, every input can only have one output. So the input here is the time. So for example, let's say the time is 3 hours. Someone who studies for 3 hours could get a 90% on the test. However, someone else who studies 3 hours may get a 70%. So therefore, this is not a function because every input, so in other words, time, does not have one output grade. Let's try another example. Are the NBA basketball teams a function of the states? So if the input are the states, the US states, and the output are the NBA basketball teams, does that represent a function? So we need to ask ourselves, does every input, so states, have only one NBA basketball team? So I would never ask this question on a test because you kind of need to know basketball teams and what basketball teams play for each state to know this question. So if you don't know the basketball teams, just understand that this would not be a function. So for example, if my state, let's say, was California, it does not have only one basketball team. So for example, I could have an ordered pair. The first one, the input be California, and then the LA Lakers. But I could also have California, and the Clippers also play in California. So every X, if X is the California and Y is the basketball teams, every input, every X, does not have only one output. I found an example where that's not the case. So we would say no, because every state, for example, California, does not have one NBA basketball team. For example, California has the LA Lakers and the Clippers. Problem 3. Is the price a function of the item? So if we let the input be the item on the menu and the output be the price, we want to know if this is a function. So you should be asking yourself, does every input, so item on the menu, have only one output, price? So if we look at the menu, a plain donut costs $1.49, so it has one price. Jelly donut is $1.99, so it has a price. And chocolate donut is $1.99. So even though the chocolate and the jelly cost the same, it doesn't matter because each donut has one price. So we would say yes. Every input, so item on the menu, has only one output price. Now if we switch this around and we had the price be the input and the output be the item, then this would not be a function because every price doesn't have one item. For example, when the price is $1.99, it has two outputs. So since the problem wasn't like that, it is a function. But if we switched it around, it would not be a function. Problem 4. Kyle is draining his bathtub. There are 40 gallons of water in his bathtub before he starts to drain it. The water drains at a rate of half a gallon per minute. So imagine Kyle, he has a bathtub, it's full of water, and now he needs to drain it. So we need to identify the input, which we also can call the independent variable, and the output, which is also called the dependent variable. So we need to decide, is the amount of water in the bathtub, or is the time the independent variable? So go ahead and pause this video and go ahead and complete A and B. Once you're done, push play and see if you are correct. So hopefully you're thinking the amount of water in the bathtub depends on the time the bathtub is left to drain. So the more time, the less water that will be in the bathtub. So therefore, since the amount of water depends, it is the dependent variable, and that leaves us with the time as the independent variable. Part C asks us to write an equation, so we are going to need some variables. So I'm going to go ahead and have T represent the time the pool drains, and I'm going to have A, capital A, be the amount of water in the, this was a bathtub. I had pool here, but it is a bathtub. Okay, so the amount of time is the independent. So that means the amount of water should be first and then the equal sign. And there is 40 gallons of water in the pool. And then he is taking out a half a gallon every minute. So T is the minutes. We could also write that equation as A equals, we could put negative 1/2 T, and since the 40 is positive, we could put plus 40. So we could put the constant at the end. We could also, if we prefer fractions, we could also put negative 0.5 T plus 40. We could also write the amount of water is equal to 40 minus 0.5 T. So those are the 4 different ways we can write the equation. Okay, part D asks if this is a function. So remember, a function means for every input, so does every time, have only one output, amount of water. So for example, if I were to plug in for T a 0, a time of 0, when we plug in a 0 here, we're going to get A equals 40. So for example, when we do negative 1/2 times 0, this is going to be 0, and we're just left with 40. So we only have, when we plug in an input of 0, we only get one output of 40. We didn't get two numbers. So another example is, let's say we have the time be 2 minutes. If we plug in a 2, negative 1/2 times 2, half of 2 is 1. So 40 minus 1 would be 39 gallons of water left in the bathtub. So every input has only one output. So if I were to plug in 2 again, I'm going to still get 39. I'm not going to get a different amount of water. It's going to be 39. So this would be yes, because every time has only one amount of water in the bathtub. We could also say yes, because every input has only one output. In the next two problems, we are given a set of ordered pairs. So we're given a relation, and we have to determine if it is a function. So we need to look, let's say the first value is x and the second value is y. So does every x have only one y? And in this problem, yes. We could say yes, because every x has only one y. Or we can say yes, because every input, so we could use the word input instead of x, has only one output, and we can use output instead of y. So if we look at example 6, does every input have only one output? So in this problem, no. If we look at when x is 3, so if we let the first number be x, it doesn't have one output. Here it has a 2, and here it has a negative 2. That's two different outputs. So no. So no, because every x does not have only one y. When x is 3, it has two different outputs, 2 and negative 2. I could also instead say, instead of x and y, I could put because every input does not have only one output. Example 7 has student names as our input. So whenever you see one of these diagrams, the input is always listed first and the output second. So does every student have only one grade on their test? So if we look here, Angela received a B on her test, Aretha a C. So it looks like every student has only one grade. It's okay that they got the same grade because the input is the students, and every student has only one output. So this would be yes. Yes, because every student has only one Chapter 5 test grade. Another way to tell if a problem is a function is to use the vertical line test. So keep in mind that vertical is this way. So the vertical line test can be used to tell if a graph is a function. So what the vertical line test says is a relation is a function if any vertical line touches the graph only at one point. So remember we said to be a function, every input, or x, can only have one y value. It should make sense then why the vertical line, like for example this vertical line, should only intersect the graph once. So if I find a spot where a vertical line would cross the graph, automatically it is not a function. So if we take a look at this example here, this problem, this graph, is a function because no matter where I draw a vertical line, so for example, if x is 3 and I draw a vertical line through it, there is only one point on the graph. when x is 3. So let's say I draw a vertical line when x is 2. It only touches the graph once right here. So no matter where, let's say I go through -2, it only touches the graph once. So if I draw my vertical line here through the origin, it only has 1 point. So no matter where I draw a vertical line, it only touches the graph once. So this graph is a function. If we take a look at the next graph, if I draw a vertical line through 1 here, it only touches the graph once. However, it does not pass the vertical line test because, for example, if x is 3, if I draw a vertical line here, it touches the graph up here, and it will touch the graph down here. So automatically, it is not a function because it touches more than once. Again, it touches here and here when I put a vertical line through at x equals 3. So even though it's okay right here when x is 1, automatically if I find a spot like that, it is not a function. Here's another spot. When x is -2, if I draw a vertical line here, it touches down here and up here. So it touches more than once, so that's why it's not a function. Okay, example 8, we are asked if this is a function. So yes, every input has only one output. So we could put that as our answer. Notice our input is our x-axis or horizontal axis, and then our dependent variable, the cost, is our output variable. So for example, if I purchased 10 gallons of gas, the cost is $40. It has one output. When the cost is $20, it has one output. Now another answer we could put is, yes, it's a function, but our explanation could be the graph passes the vertical line test. Any vertical line that we would draw through our graph crosses the graph only once. So for example, if we draw a vertical line here, it only touches once. So no matter where we draw our imaginary vertical line, it touches once. Okay, so if we take a look at example 9, here we have a graph of the number of hours studied and grades on exams. So we have to check if it meets the definition. Does every x, so if the number of hours studied was x and the grade was y, does every x have only one y? So if I use the vertical line test here through 6 hours, we could see it has a point here and here. So when the number of hours studied is 6, for instance, it doesn't have one output. Also, for example, when the number of hours is 4, it has a point here, here, and here. It crosses 3 times. So we could say no, because every input does not have only one output. For example, when the number of hours is 6, it has 2 different outputs. We could also say no, because the graph fails the vertical line test. For example, if I draw a vertical line when the number of hours studied is 6, so right here, we draw a vertical line, the vertical line will touch more than once, so it will touch this point and this point. Example 10, we are given a graph. We are asked if it's a function, so I would pause the video, try it yourself, and push play when you're ready. So hopefully you're thinking, no, it's not a function. So we could say no, every input does not have only one output. For example, when the input is 8, it has two outputs of 6 and 18. We can also say no because the graph fails the vertical line test. For example, if I draw a vertical line when the input is 14 right here, so if we draw a vertical line, it will touch the graph more than once. So if we take a look at example 11, it is a function. If we wanted to use the vertical line test as our justification, we would say yes because the graph passes the vertical line test. Any vertical line crosses the graph only once. So for example, if the number of items is 8 and we draw a vertical line through 8, it only touches the graph once. So there is no vertical line that will touch the graph more than once. We could also say yes because every input has only one output. In question 12, we are asked to circle the graph or table if it is a function. So the first 4 are graphs. So it would be pretty easy to look at and use the vertical line test. So for example, graph A, no, not a function because if I use the vertical line test, it touches, I found a spot where it touches more than once. So B, no matter where I draw a vertical line, it only touches the graph once, so B is a function. Same thing with C, it would only hit the graph once. And D would be no, because when I draw a vertical line, it touches more than one point on that blue graph. So, whoops. So just B and C are functions. So now with the tables, we can look and see, does every X have only one Y? So if we look at choice E, all the X's there have only one Y. It's okay that these are the same. So I can also back it up if I want to use the vertical line test as my justification. If I draw a picture, so if I go to -2 on the x-axis, down to 3, there's my point. And then if we go to 1 and -3, or 1 and 3, and then 3 and -3, and then 5 and 3. So if I draw a vertical line here, it only touches once. If I draw a vertical line here, it touches once, here, once, and here, once. So it also, if the vertical line test is easier for you, you can also plot the points and see if it passes the vertical line test. So E is a function. If we look at all the x's here, they each have one y. So if it's easier for you to see, you can make a graph. So if we plot all the points, if we draw a vertical line here, it only touches once, here only touches once. So every x has one y. It's okay that they're all the same. So f is a function. Now if we take a look at g, it is not a function because when x is 3, it has two different y values. So if we were going to draw a picture of this, when we go to 3, it's going to have a point up here at 4, and it's going to have a point down here at -4. So if we draw a vertical line, it's going to hit twice when x is 3. So g is not a function. Okay, lastly h, if we look here, all the x's have one y, because even though the x repeats here, it has the same y value. So it'd be like somebody who made a table and plugged in -1 accidentally twice, it still gives you the same output. So for example, if I were to draw a picture of this, and we go to -1, -5, when x is -1 here, it only has that 1 point at -5. So even though the x's repeat, every x, for example -1, has only one y. So h is also a function. So B, C, E, F, and H all are circled and all are functions because every x has one y.